Hi everyone, you're welcome to DML Physics Concepts. Thank you for joining this class. Make sure kindly you subscribe to this YouTube channel, like this video, and you can pass comments. And at the same time, make sure you please share this video to your friends and share it to everyone so that they can enjoy of this class. And at the same time, you can turn on the notification bell that anytime I upload a new video, you'll be notified of those videos. Now, in previous classes, we started by looking at resolution of vectors. We have resolved vectors, two vectors acting in the same direction, in opposite direction, at 90 degrees to each other, and at acute or obtuse angle to each other. What I'm saying is at angle theta to each other. Then today we now want to look at a case of to resolve vectors that is more than two. If you want to find resultants of more than two vectors, how do we do that? And remember that before now we have also done something of resolution of vector where I said that every vectors always have two components. We have the vertical component of force and the horizontal component of force, where I said the vertical component of force is V equals to V sine theta, while the horizontal component is V cos theta. That's V equals to V cos theta. So let's look at an example. Let's consider this diagram. Alright, let's look at this diagram. Let's say we have 6 forces acting on this point. F1 acting in this direction, F2 acting upward, F3, F4, F5, F6. They can be more than these vectors and they may not be up to these vectors. But let's say we have 6 vectors acting on this point. So how do we resolve this vector? Remember that every vectors as we are looking at it, they have vertical component and horizontal component. So each of them has vertical component, horizontal component, vertical component, and horizontal component of force. Separately, they all have their vertical component and horizontal component of force, whereby there's going to be an angle theta between them. What is the angle theta? An angle theta is the angle between that force we are talking about and the horizontal. So what's the horizontal? This is our horizontal. This is our horizontal level. So the angle between any of the force to this horizontal, so this is the horizontal here. So this is our horizontal line. So the angle between each force and the horizontal is their angle theta. So let's say for F1, let's say F1 has theta 1. So which means the angle between F1 and the horizontal is theta 1. So let's say with F5. F5 also have, let's say, theta 5. That is angle between the force, this force, and the horizontal is theta 5. Remember, this is angle between the vertical. This angle here is angle between F5 and the vertical axis, but we are not dealing with vertical. Remember, our angle theta is always angle between the force and the horizontal. So let's say our F4, this is our F4. Let's call this place our theta 4, and this is let's call this place our F theta 3. So the angle between F3 and this horizontal is theta 3. But let's look at it. We have other forces. Now we know that F1 is theta 1. We know that F3 is theta 3. F4 is theta 4. And F5 is theta 5. So what's going to be angle for F2 and F6? So for F2, the angle between F2 and the horizontal, if you look at it, F2 is like this. F2, and this is the horizontal. If you look at it, the angle between F2 and the horizontal is just 90 degrees. So you have to get that clear. So everything now, the angle between F2 and its horizontal is 90 degrees. But what of the F6? For the F6, pardon, now for the F6, this is the horizontal. And we look at the F6, F6 is directly, this is the horizontal, the F6 is directly on the horizontal. It means F6 is parallel to the horizontal axis. So the angle for F6 is 0 degrees. So for F2, its angle theta is 90 degrees, while for F6, its theta is 0 degree. It's 0 degree, or you can say 180 degree, and 180 degree is also 0 degree to the horizontal. So that is that about that one. So we already have F1 and their angles. We have all these forces and their angles are there. Now let's now find the resultant of this vector. So there are two methods of finding the resolution of vector, but I will use the two methods. I'll first write the first method, then I'll look at the second method. Alright, don't forget this. Let's put it at the back of our mind that for F2, the theta for F2 is 90 degree, while for F6, its theta degree is 0 degree. So I can claim this side of the board. So let's clean and let's resolve now. So let's use the tabular method. Let's tabulate it. Let's have a table. We have a table for force, which is in Newton. Let's have a table for theta, which is the angle between the resultant vector and the horizontal. And let's have a table for the vertical component, what's going to be our vertical component of the force. And let's have a table for the horizontal component of the force, that is V, horizontal component of the force. Now let's put it at the back of your mind that vertical component is V what? V sine theta, while horizontal component is V cos theta. Alright, let's fill these parameters. We want to resolve this component. So let's resolve the vertical and the horizontal component. So let's first list these forces here. So we have F1. And what is the angle of F1? F1 is theta 1. Then we have F2. What is the angle of F2? Remember we said F2 is 90 degree. So F2 is 90 degree. Then what is F3? The angle of F3 to the horizontal is theta 3 degree. Then what is F4? F4 is also theta 4 in degree. What is F5? F5 is theta 5 degree. Then what is F6? Our F6 is what? 0 degree, because F6 is directly parallel to the horizontal. So let's find the vertical component of the force now. So for this one, the formula here is going to be F1 sine theta, because if F is, because we are dealing with V vector, but our vector in this case is force, so I can rewrite this one. This formula can also be written as F, because we are dealing with a vector. Our vector in this case is a force. Remember, force is an example of a vector quantity, so I can just use F instead of using V. So this is our F now. So in this case, we can now say for this particular force, F1, its vertical component is going to be F1 sine theta 1. While its horizontal component is going to be F1 cos theta 2. So let's write that. For this one is going to be F1 sine theta 1. While its horizontal component is going to be F1 cos theta 1. So for this one, its own vertical component is going to be F2 sine 90 degree, while for its horizontal component is going to be F2 cos 90 degree. So you have to get it right. I'm still applying this formula to resolve this component. Remember, each forces, as we are looking at it, has vertical component and horizontal component. So this force has vertical component. Its vertical component is F2 sine theta. And what is this theta? Theta is the angle between that force and the horizontal, which we said is 90 for F2. So for F3 is going to be F3 sine theta 3. This one is going to be F4 sine theta 4. And this one is going to be F5 sine theta 5. And why this one is going to be? This one is going to be F6 sine 0 degree. So why this one is going to be F3 cos theta 3. Although this process may be long, but is one of the method of solving resolution of vectors when we have more than one vector. So this one is also F5 cos theta 5, and finally we have F6 cos theta theta 6, and here theta is 0 degree. Now, so the next thing is now we want to find the overall. What is the overall result for the vertical? What is the overall result for the horizontal? So what is going to be the final Fy? That is when I add this together. So whatever the result is my total value for vertical component. And when I do this one also for Fx, when I add this together, whatever the result is going to give me is the total result for the horizontal component. So let's just call this one, y-axis, and let's call this place x-axis. Whatever result this one give me is going to be y, and whatever result this one give me is going to be x. But something I want us to understand is that we are dealing with y-axis and x-axis, and y-axis and x, we are saying that we are resolving this component in a vertical and horizontal. For vertical component, there is an upper part, there is a lower part. So there is a positive y-axis and negative y-axis. So let's look at this. So this one is the positive for the vertical, and this is the negative for the vertical. This place is the positive for the horizontal. This is the negative for the horizontal. So any forces that points in each of this direction in the vertical, we need to put whether this one is a positive or negative. You need to put it at the back. That's why I leave space here. So let's put it whether it's positive or negative. Now, don't mix the two together. Now we want to look at vertical. This one is vertical. So for vertical, so I have to remove this horizontal. I only want to look at vertical now. If I look at vertical, you discover that in vertical direction, you discover that F1 is pointing upward. F1 is pointing towards the vertical direction. This is F1. It's pointing towards the positive direction. So F is positive. Let's look at F2. F2 is also pointing in upward direction. It's pointing in this direction. F2 is also positive. I'm looking at vertical component now. So let's look at F3. F3 is also pointing towards the up direction. So F3 is also positive. But let's look at F4. F4, this is the middle. And F4 is already pointing downward. Because F4 is pointing downward, this is a negative. It's pointing towards the negative direction of the y-axis. So F4 is negative. If you look at F5, F5 is also pointing downward. It's towards the downward side. F5 is pointing downward, so it's also negative. But let's look at F6. F6 is in between. F6 is pointing like this. This is F6. So you look at F6. F6 is neither pointing up, it's neither pointing down. So it's neither positive nor negative. So it's 0. So because it's 0, you cannot say 0 is negative. So we take it as positive. So which means the positive of this, positive of this, positive of this, negative of this, negative of this, and positive of this is going to give us the resultant value for the vertical component. So let's do the same thing for the horizontal. So you can just go through this video and recap. So let's do the same thing for the horizontal component. So for horizontal component, I will have to clean this one. So let me clean this and let's look at for the horizontal component. So for horizontal component, we are going to look at this component again in horizontal direction. So we want to look at it in horizontal direction. So we want to know whether this force is pointing is positive or negative as far as horizontal direction is concerned. Remember, for horizontal direction, this is the positive x-axis, this is the negative x-axis. So in this point, let's look at it. Look at F1. F1 is pointing in this direction. We are not looking vertically again, we are looking horizontally. So F1 is pointing in this direction. That is pointing towards the positive. So F1 is also positive. Look at F2. F2 is pointing upward. So F2 is at the center. So it's neither pointing this direction nor pointing this direction. So it's at the center. So because it's neither pointing towards the positive nor pointing towards the negative, it means it is pointing at the middle, which is 0. So we'll take it as positive as well. You cannot say 0 because it is neither positive nor negative. So we are going to take it as positive because this is 0, the middle point. And if it is 0, 0 is not a negative value, so we take it as positive. So let's look at F3. If you look at F3, F3 is now pointing towards the negative. It has exceeded the 0 point. It's pointing towards the negative. So this one is negative. What is F4? F4 is still in this direction. It's also pointing towards the negative direction. It's also negative. F5 now. F5 as point is pointing towards this direction. So F5 is positive and F6 is positive. So you have to take note of that. So the addition of this one also is going to give us the result for y. So in conclusion, we can now say for y, our y component is going to be F1 sine theta 1 plus F2 sine theta 2, no, theta 2 is 90, sine 90 plus F3 sine theta 3, then minus, because of this one, minus F4 sine theta 4, are you following? Then minus F5 sine theta 5, then plus F6 sine 0 degree. Whatever this one give me as a final result is the value for my y component. So let's look at the value for x component now. So for the x, our x is going to be, this is our x, this x now is going to be f1 cos theta 1 plus f2 cos 90 minus f3 cos theta 3, so you have to follow, minus f4 cos theta 4, then plus f5 cos theta 5, then plus f6 cos 0 degree. So whatever this result gives me is going to be our result for vertical component. So we are going to get a single value for this, we are going to get a single value for this. So here we have resolved this whole component of vector into two. We have resolved all these vector components, everything vertically, and we have resolved it horizontally. So we are going to have two vectors now. Remember, we are doing resultants of more than two vectors. But what we want to achieve is all these vectors must be resolved into two. We have to change it, sum it up to make just two components of vector, which is going to be vertical and horizontal. So what we have done here is we have resolved the whole vector component. There are 6 of them, but we have resolved it into just two. One vertical, one horizontal, whereby the overall vertical component is y, overall horizontal component is x. So we are going to have x value and y value. So this one is going to give us a value, and this one is going to give us a value. Now that he has given us a value, so the next thing is we are now proceed to resolve this one now. So let's resolve it. So now we are going to have two values. So one representing the y-axis, one representing the x-axis. So which means, so this is the y-axis. So whatever the result of this one is going to be our y-axis, and whatever the result of this one is going to be our x-axis. But how are we going to draw this? Are we going to draw it this way, or we are going to draw it this way? Remember, vector must have magnitude and direction. But in this place, we only have their resultant value in magnitude, but we don't know the direction. So how are we going to know the direction? So let's look at it. It's very straightforward to know the direction. It's going to straightforward. That is, are we going to draw it in any of these four ways? So we are going to draw it in any of these four ways. In any of these four ways. So just pay attention to it. It's straightforward. So what I'll just enjoy is just you can just go over the video, and if you have any questions, you can just ask. So remember, this is the y, this is x-axis, this is y, this is the x-axis, this is the y value, this is the x value, and this is the x value, this is the y value. So what's going to happen is that we have four cases: 1, 2, 3, 4. Now if you solve this one, let me start from the y. If you solve this one and the result you get here, please pay attention now. If you solve this one and the result you get, the result of this thing can be positive value or negative value. If you solve this one and the result you get is a positive result, that is positive result, and you solve this one, here you also get a positive result, then it means your y-axis will point towards the positive y-axis, while your x will point towards the positive x direction. If the result is positive, let's say plus 5, and let's say this one is also is plus 4, so let's assume it's plus 5 plus 4 as final result. So we are saying that for y-axis, you are going to draw something like this. That is, your arrow must point towards the positive of y, and while your x will point towards the positive of x. So we are going to find this one. So we just do is that if the two answer is positive, so you just put 5 here, you put 4 here. Yes, you put 5 Newton here, you put 4 here. So it has now become two vectors that is acting at 90 degrees to each other. So from here, you now proceed to how we resolve two components of force that are acting as 90 degrees to each other using Pythagoras theorem to find our resultant. So our final resultant we will find using Pythagoras theorem. Why our direction is going to be the angle between them, which is our tan alpha. Now, if that is the first case. The second case is, if you look at this one, I would like you to think what's going to happen here. It means in this case, when you resolve your y value, our y value is positive because it's pointing positive direction. Why? What's our x? our x give us a negative, because this direction it is pointing is a negative x direction. Look at it. This is the negative, this is the positive. So in this case, if it is negative, if x is negative, so let me just put it here y is positive, y x is also positive. But in this case, when y is positive, but where positive, y x here is negative. So if that's what you get here, you are going to draw it this way. For this case, and you find the resultant by drawing, is going to be your resultant, and then you find Pythagoras theorem, and this is going to be your direction, the angle between that resultant and the horizontal. So for this case, in this case, if you look at it here, x is positive, but here y is what? Negative. So if y here is negative result and x is positive, you are going to draw something like this. So you find your resultant in this direction. These are resultant using Pythagoras theorem, while your direction is angle between the resultant and the horizontal, which is how far. For this last case, you see that x here is what? When if the x result is negative, look at it, if x result is negative and the y result here is also negative, so we are going to find our resultant also in this way, whereby your angle direction is going to be angle between the resultant and the horizontal. This angle is going to be our direction. So it's as simple as this. But without going over this stress, there is a way we can solve it without going through this stress. But to do that, to resolve this component without going all through this stress of drawing a table, they are just a concept. And the concept is you must put the sign at the back of your mind and component in mind. Put the sign, because you must put sign. You need a sign, whether it's plus or minus. You put it at the back of your mind. After I put it at the back of your mind, then the component you are dealing with, is it vertical component, horizontal component? You put the two at the back of your mind. So let's quickly look at the second method and see how we resolve without going through all the stress of this table. But at the end of the whole thing, after you have gotten your x value and your y value, you still have to proceed to these values, to this concept, to find your final result, the resultant in magnitude and direction. Okay, let's resolve this one without having to draw the table, and let's simplify and see what to do. Remember, what we need to do is what? Bear the sign in mind, SIGN, the sign in mind, and bear the component in mind. That is it a vertical component or horizontal component? Recall that for vertical component, y is v sine theta, and horizontal component is v cos theta. So let's now put it at the back of your mind. Let's resolve. So let's first resolve for the vertical component y. What's going to be our final result for y? Our y is going to be, put the sign at the back of your mind and the component. So you first start with f1. So for f1, I want to start with this first f1. I will do it f1, f2, f3, and f4. So let's start with f1. f1, put the sign at the back of your mind and the component. And what's the component we are dealing with? Vertical component, y. If you look at this, f1 is pointing towards the positive direction. Look at it. This is the y-axis. This is the positive y. This is the negative y. So putting the sign at the back of your mind. So f1 is positive of y-axis. So f1 is positive f1, and the components is sine theta 1. Now what of f2? f2 is neither pointing upward. f2 is pointing like this. It's neither pointing up nor pointing downward. So it means f2 is also positive. It is not pointing up. It's not pointing towards the positive y-axis, not pointing towards negative. So it's in between. So it's 0. So we have plus f2. Remember the component sine theta. And what is theta? Theta is always angle between that component of force and the horizontal. And the horizontal, you see that is 0. It's 0. This is the f. This is the horizontal. And f is already aligning on the horizontal. So the angle is 0 degree. f2 is aligning on the horizontal. So it's 0 degree. So 0 degree. Now let's say f3. You see f3 is now downward. So that will be minus f3 sine. What is the angle between f3 and the horizontal? 90 degree. So 90. Then what of f4? f4, is it minus or positive? f4 is positive. Why? Because f4 is pointing this direction too, and f4 is neither pointing upward nor pointing downward. Remember, we are looking it in vertical. It's a vertical component we are doing now, so it's also positive. That is plus f4 sine. What is the angle between sine f4 and the horizontal? It's also 0 degree. It's 0 degree to the horizontal. So this is whatever the result this one give me is my y value. So let's look at the x. Our x is going to be, now I want to resolve in horizontal direction now. So let's resolve in horizontal direction. So this horizontal direction, we want to look at the x. For the x, anything that points here is positive x-axis, anything that points here is negative x-axis, and anything that points in between will also be taken as positive. That is neither up or down. So let's look at that now. For x, so what is f1? It's pointing this direction, so it's positive f1. But we'll not say sine because it's s. X is cos theta 1. Now what is f2? It's also positive because it's pointing this direction. f2 cos. What is the theta here? 0. Cos 0. Now what of f3? f3 is in between. It's neither pointing, f3 is pointing at the center like this. It's pointing downward. It's neither pointing here or pointing here, so it's also positive. Plus f3. And what is the cos? The angle between here and the horizontal is 90. Cos 90. And what of f4? Is f4 minus or positive? It's pointing towards this direction. So it's negative, minus f4 cos. What is the angle here? Angle between this f4 and the horizontal is parallel to the horizontal, so it's 0 degree. So this is how we resolve the component. So bearing the sign in mind and the component in mind, we can also resolve this component. So kindly subscribe to this YouTube channel. You can also check this video and watch again. So the next class we now begin to apply. We apply values. We put values here, and you now see the true picture of how we solve the component. And don't forget, whatever this sign is, whatever the result is, whether it's positive or negative, is going to determine how we are going to resolve our component. Whereby, if I'm drawing this way, it means I'm saying y is positive, and it means our x is also positive. So it depends on whatever the result we have here that will determine how we are going to draw this. Make sure you like this video. Next class, I will go into details on how to apply this concept and solve examples as we have it. Thank you for watching this video, and God bless you.